In example 3, we're going to use the same trig ratios, but we're going to try to solve multiple triangles and use different 90-degree triangles to try to find different things. So here we're going to solve for QS, ST, and RT, and we're going to do it in that order because it makes the most sense, which is why they asked you to do it. So first of all, QS, that's the side from Q to S. So that's from here to here is what we're looking for. So we have a right triangle here. In fact, the only side that this is a part of is this big right triangle. So QP. So here's our right angle. In this case, this is our hypotenuse. And this is the only angle that we have. So this is our angle. So this would be our adjacent. And over here is our opposite. So right now I want you to try to ignore all the other angles or all the lines in there and just look at this big triangle. So we have the opposite, and QS, we're looking for the adjacent. So opposite adjacent, we're looking for tan. So QS, we're going to use the tan of theta is the opposite over the adjacent. And again, I can't stress enough to at least have these written down once somewhere so that you make sure you're substituting in the right things. So the tan, I usually write it every single time. The tan of 26 degrees, that's our angle, is the opposite, which is 12.5. It'll help if I write this right. So 12.5 over my adjacent was what I don't know, so that's x. X is on the bottom. It's going to be a division problem. Okay, so x is equal to 12.5 divided by the tan of 26 degrees. So I'm just switching these two things around. So put that into my calculator. So 12.5 divided by the tan of 26, and again, make sure you know how your calculator works, and x is equal to 25. I'm going to go to one decimal place, so 25.6 centimeters. So that is QS. Next thing I want to find is ST. Let's change the color, or maybe we won't change color. There we will, just so we can see what we're doing here. So now ST, I'm actually going to erase all my markings on here, just because I'm probably going to want to use some different things. But I do know now, I'll go back to blue just for this, that this is, I think I just picked it, whatever, 25.6 centimeters is that side. So now I want ST. Well, ST is from here to here. And again, I need a right triangle. So I look and I just found that 25.6, so I probably need to use that. And what triangle do I have? Well, it's this one here, S to T to Q to S. There's a 90-degree angle here. Oops, 90-degree angle here, and I have this angle. So here's my 90 degrees, and if I look, so I'm just going to kind of draw on my triangle so you can kind of see which one I'm referring to. So across from that, this is the hypotenuse, and this 26, this is the adjacent, and this one over here is my opposite now. Okay, I want ST, that's the adjacent, and I have the hypotenuse because I just found it. So adjacent and hypotenuse, that's cosine. So cos theta is adjacent over hypotenuse. Okay, so cos, again, I know my angle is 26 degrees. The adjacent is what I'm looking for. I'm going to call it y. Over the hypotenuse, I could call it st if I wanted. Over the hypotenuse, which is 25.6. Okay, y is on the top, so I'm going to multiply the things that are diagonal from each other. So y is equal to 25.6 times cos of 26 degrees. So again, I want to put that into my calculator. So 25.6 times the cos of 26 degrees. That gives me 23.0 centimeters. So ST is 23.0. And again, I'm going to erase all the stuff that I have here because I'm probably going to, except for the measurements that I've calculated, oops. So let's put that back in. It's 25.6. So that's QS. And this is ST. And the last thing I want to find is RT. So I'm going to change my color again. Let's go red. And I want to find RT, which is this side right here. So look at what I have. Well, I could use this triangle, but that's not very useful. But I do have these two sides. And I want to find RT. So I'm looking for this. I'm going to call that my Z. We're going to look at this, and I do have this side of that triangle, though, and I have this angle still. So I could use a squared plus b squared. I have to do a lot more work. So here's this. Here's my right angle, so I look across. Now this is my hypotenuse. This is my adjacent. This is my opposite. So opposite hypotenuse, now I'm looking at sine. So I want RT is sine theta is equal to opposite over hypotenuse. So sine 26 degrees is equal to opposite, Z, over the hypotenuse, 23.0. And now it's a multiplication, so Z is equal to 23.0 times the sine of 26 degrees. And Z is equal to 23 times the sine of 26. And I get 10.1. So there we have RT is 10.1.